Alright, and welcome to Analyzing Quadratics Level 2. Now, here in example 1, we have a much more complicated problem because we notice that our a value, a, is not equal to 1. Now for part A, I want you all to go ahead and find the solutions, and remember we could call these the roots or the x-intercepts, or we could even call them the zeros. So when a doesn't equal 1, what do? Well, what we want to do is still set our f of x equal to 0. However, we always want to see if we can factor out a from everywhere. So I factor out my -4, or I divide everything by -4. Comes out to the front. And since 4, 32, and 60 can all be divided by 4, we're in good luck. So that reduces to 1. And so I basically have 1x squared. -32 divided by -4 is positive 8x. And -60 divided by -4 is positive 15. So, dropping down. Now that I have this a value equal to 1, I can split this into two factors, where I know that x times x gives me x squared. And I want to take a look at my c term. And I want to see if I can find two numbers that multiply to be 15, my c term, that add up to be my middle term, my b term, positive 8. My only options are 1 and 15, and 3 and 5. Well, I know that 1 times 15 is 15, but 1 plus 15 is equal to 16. And remember, I was looking for a positive 8, so that's not right. Here, I can add 3 plus 5, which is 8, and hey, that's the middle term. So x plus 3 and x plus 5 are my two factors. Now from here, I know I want to take my factors and I want to always set them equal to 0, because 0 times anything is 0, or 0 times anything is equal to 0. And from here, all I have to do is solve for x. So -3, and I get x equals -3, and I subtract 5, and x is equal to -5. And so over here to the right, I'm going to write my zeros are x equals -3 and -5. And we're just going to kind of keep them over here for now. Remember, my quadratic will cross the x-axis at -3 and -5. Pause the video and finish taking any notes that you need to. Alright, here for part B, I want to go ahead and see if I can solve for the vertex. Well, this is a little bit trickier because we still want to separate out our x squared and our x term from our imperfect constant. However, now that a is not equal to 1, we know that we need to factor out that -4. So I'm going to factor out -4 from these first two parts. I can write f of x equals -4, because it factors out. And then we have our parentheses, where -4 divided by -4 leaves us 1x squared, and -32 divided by -4 leaves us positive 8x. We leave our space for our perfect constant and push aside our -60. Well, here I know that my b term is this positive 8. So when we use our b over 2 squared formula, I can do 8 over 2 squared, and 8 divided by 2 is 4 squared. Well, what is 4 squared? Let's use a different color here and say that 4 squared is actually 16. And so I can put plus 16. Now this is where I get a little bit concerned. So notice I didn't actually add a positive 16. I added a positive 16 times -4. So what is positive 16 times -4? That is actually a -64. So what do I need to balance out a -64? Well, a positive 64. And from this point, I can start to simplify my final problem. I have f of x is equal to -4, parentheses, x plus or minus something squared. And remember, when I'm taking my trinomial and I'm writing it as a perfect square, I'm looking for the number that can add up with itself to be 8 and multiply with itself to be 16, and it will always be half of our b term. 8 divided by 4, or 8 divided by 2 is 4. Look, 4 plus 4 gets you to 8, and 4 times 4 gets you to 16. And then right over here I have -60 plus 64, which will give me a positive 4. Now, when I go to write my vertex, I can easily find out what my vertex is from here. I know that my constant here is my 4. It's my y value of my vertex. And I always set my grouping equal to 0. Well, how do I get x by itself? I simply subtract 4 from both sides, and x is equal to -4. And now that I have my vertex and my zeros, I can truly graph my function and analyze every remaining factor. Pause the video and finish taking your notes, and let's finish this problem. Okay, now we're going to go ahead and graph our quadratic, and we always want to start with our vertex. So at -4, let's see, 1, 2, 3, 4, we go up 1, 2, 3, 4, we have our vertex. Now notice our a value is negative, so we're going to start to open down. And I want to figure out, well, where am I going to cross my x-axis at? My zeros are over here to the right, and we have one at -3, so 1, 2, 3. And if we go, here, let me even use green, 1, 2, 3, and then we go to -5, so there's -4, and then here's -5. We notice our graph is super skinny as it opens down. Now it's still going to continue to get wider in both directions, but just know it starts off very narrow. So what are all the things that we know? Well, let's start with our axis of symmetry. Our axis of symmetry. Okay? We see that our x value is -4, so that's at x equals -4. And that should make sense because over here in my vertex at -4, I can just drop straight down. Okay? I notice that my y value is 4, and this is at the top of the quadratic, so it must be a maximum. So we can say that we have a maximum at +4, okay, or a max at 4. The last couple things that we want to talk through, and I'll use a different color here. Oh, let's go with this nice color, is we want to talk about our domain. Well, even though it looks like this kind of stops getting wider, this really goes forever to the left, aka -infinity, and it goes forever to the right, aka +infinity. So we can say our domain is all real numbers. And you can use the fancy symbol R for all real numbers. Lastly, let's go ahead and talk about our range. And this one's probably the trickiest one. So we have our bracket, y such that y. And you always look at the y value of your vertex. You say, hey, how high is my vertex? Well, it's a max at 4. So we're going to compare y to 4. And you ask yourself, well, how does the graph compare to 4, the highest point? Is everything above that point, or is everything below that point? And since everything is below 4, we see that we'll say y is everything below 4, or y is everything less than or equal to 4. And there you go. There's your axis of symmetry. There's your maximum at 4. We have our domain is all real numbers. Our range is every value less than or equal to 4. And we even see that we have solutions or roots or x-intercepts or zeros at -3 and -5. And that's it. That's everything there is to a quadratic. I hope this was helpful. And after this assignment, I am asking you, please start working on your missing work. Y'all have a great day.